We are on video 3 in a very, very long sequence of videos on solving linear equations and linear inequalities in one variable. So I am going to do this series in 3 parts. Part 1 is going to be solving linear equations in one variable. Part 2 is going to be problem solving, so word problems. And then part 3 is going to be solving linear inequalities in one variable. So we're on video 3 where we're going to solve multi-step equations. The previous videos, we looked at what is an algebraic expression, and what can we do with algebraic expressions? And we found that we can evaluate or we can simplify. Video 2, we introduced the idea of an equation. So what is an equation compared to an expression? And what's the big difference? The big difference is that you can solve equations. They have an equal sign. So we looked at 2 properties that help us solve equations: the addition property of equality, which allows us to add or subtract on both sides of the equation, and then the multiplication property of equality, which allows us to multiply or divide both sides of the equation. Those were just one-step equations. So now we're going to kind of up the ante, and we're going to look at equations that we would have to do multiple things in order to find the solution. So let's go to the whiteboard and take a look at these multi-step equations. Okay. So first of all, we need to review a couple of definitions. The first definition is solving. So please recall that solving is the process of isolating the variable to determine its value. All right. So this whole first part of the sequence on solving linear equations and linear inequalities is all about just solving equations. So solving is the process of isolating the variable to determine its value. So when we're isolating the variable, basically think undo. How can we undo what has happened to that variable? We then get to the solution. Let me put the solution. So the solution is the value for the variable, is the value for the variable that satisfies the equation. So the solution is kind of the end result of the solving process. So solving, we're isolating the variable, we're undoing what has happened to that variable in hopes of getting the solution, which is the value for the variable that satisfies the equation. And all we mean by satisfies the equation is we're looking for the value that when we plug it into the equation, it makes the left and the right hand sides of the equation equal, okay? And then finally, you always have to maintain balance. You can't just willy-nilly go in there and start playing around with the equation. So as you're solving, you're having to maintain balance. And the way we maintain balance is if we do something to the left, do the exact same thing to the right. And we had 2 properties that kind of allow this to happen. We had the addition property of equality, and we had the multiplication property of equality. Basically, the addition property of equality just says if you add or subtract on the left, add or subtract on the right, the same value. The multiplication property of equality says if you multiply or divide on the left, do the same multiplication or division on the right. They're forcing you to maintain balance, okay? So all of that finally leads us to the steps to solve equations. In the previous video, all of our equations, we just had to do one thing to solve. Here, we're going to have to do multiple things. So the first thing you always want to look for is parentheses, and you want to eliminate parentheses. And here you are applying the distributive property. So if you see parentheses, distribute to eliminate the parentheses. After you get rid of the parentheses, you want to combine like terms on the left and right sides separately. So basically, at the end of step 2, you want at most one variable term and one constant term on the left, and at most one variable term and one constant term on the right, okay? So basically, these first 2 steps are just cleaning up your equation. You're kind of taking cookie crumbs on a table and you're brushing them into piles. You're just cleaning things up, okay? It's step 3 where we start moving stuff around. So step 3, we want to get all variable terms together. So we want to get all variables in a single term on one side of the equation, generally the left, and all constants on the other side. All right. This is where we apply the addition property of equality. All right. And then finally, step 4, we want to divide both sides by the coefficient of the variable. This is the final step to solving. This is what's going to finally isolate that variable. And this is basically the multiplication property of equality. All right, so we start by distributing to eliminate parentheses. We then combine like terms on the left separate from the right. Next step is to get all of the variables in a single term on one side of the equation, all the constants in a single term on the other side of the equation. And then the last step is to finally isolate that variable by dividing by its coefficient. All right, so let's go ahead and just dive right in. We're going to look at some examples. And for the first few examples, I will check my solution. Okay, I'll remind you that anytime you're solving a linear equation in one variable, you can always check your solution. So we'll practice that in a few of the examples, but not all of them, just for the sake of time. All right, so the directions here would just say, solve each equation. So first up, we're going to do something really simple. Let's say that we have negative 5x plus 7 is equal to 17. Okay, so we would want to check, do we have parentheses? Well, no. So then we go to step 2. Step 2 says combine like terms on the left and the right hand side of the equation separately. Well, looking at the left hand side, can we combine like terms? No. Looking at the right hand side, can we combine like terms? No. So we're at step 3 where we want to get all the variables into a single term and then all of the constants in a single term. And if you look here, we only have one variable term. So the variables are good. However, we do have 2 constants. We want to get all of the constants on one side of the equation alone. So let's look at this plus 7. We want to move the plus 7 over to the left-hand side. Now, the way we solve is we undo stuff. So how would I undo addition of 7? Well, I would subtract. All right, so I'm going to subtract 7 from both sides. Remember, that's going to help us maintain balance. Over here on the left, the 7s cancel. We get really lazy a lot of times in math and we just say, oh, stuff cancels. Well, yes, stuff cancels, but behind the scenes, the reason the 7s are canceling is because 7 minus 7 is 0. And negative 5x plus 0 is just negative 5x. But instead of saying all that, we'll just be like, oh, the 7s cancel. Okay, so whenever you say things cancel, just know in your mind what's really causing those things to cancel. All right, and then on the right-hand side, we have 17 minus 7, which is just 10. So this is where you're almost done. You have a single variable term on one side of the equation, and you have a single constant term on the other side of the equation. This is where you do that final step to isolate your variable. We need to undo the multiplication of negative 5 and x. We undo multiplication with division. All right. On the left, again, we would get lazy and we would say, oh, the 5s cancel. Well, yeah, they cancel, but the reason they cancel is negative 5 divided by negative 5 is 1. 1 times x is just x. And then on the right, 10 divided by negative 5 is negative 2. So let's check our solution. So what we're going to do is we're going to rewrite the original equation, but anywhere we see an x, we're going to put a negative 2. So I get -5 times -2 plus 7 equals 17. All right, so I want to do first the -5 times the -2. -5 times -2 is 10. And then I've got my plus 7 equals 17. So finally, what's 10 plus 7? Well, it's 17. 17 does equal 17, so this is good. And that just verifies that our solution is -2. Now, please note those curly braces. A lot of times when you're solving, you're writing out your solution set. Well, in this case, our solution set contains the value -2. And so what we do with solution sets is we write the set of solutions inside these curly braces, okay? So neither of these is incorrect. Neither of these is necessarily better than the other, all right? X equals 2 is perfectly okay, but X equals -2, where you write it in solution set notation, where the -2 is inside curly braces, it's just a little more formal. It's kind of fancy, all right? Now, you will see me generally write my solutions in set notation, but it's up to kind of whatever product you're using and how that product wants the answer. Let's look at another example. This time, let's look at 5x minus 5 plus 3x equals -37. So in this particular case, again, I don't have any parentheses, so I don't need to distribute. But if you look at the left-hand side of this equation, we do have two terms on the left that contain variables. We don't want two terms on the left with variables. We want at most one term with a variable on the left. So looking at 5x plus 3x, I can go ahead and simplify that to just be 8x minus 5 equals -37. So we've already taken one step to clean up this equation. So now on the left, we have a single variable term and a single constant term. On the right, we have a single constant term. We're at the point where we want to get all of the variables in a single term on the left, all of the constants in a single term on the right. So I need to focus on -5. I want to move -5. I want to put that constant -5 with that constant -37. So the way I move that -5 is I undo what is happening. Remember, we're undoing what's happening to the variable. The variable is being subtracted by 5. We want to undo that by adding 5 to both sides. On the left, we say the 5's cancel because -5 plus 5 is 0. 8x plus 0 is just 8x. And then on the right-hand side, -37 plus 5 is -32. So we're at that final step. We have a single variable on the left, or a single variable term on the left, a single constant term on the right. The way we finally solve is we undo the multiplication of 8 and x. All right. Well, the 8's cancel. 8 divided by 8 is 1. 1 times x is x. And then on the right, -32 divided by 8 is -4. And let's go ahead and check our work. We get 5 times -4 minus 5 plus 3 times -4 equals -37. So we're going to do a little bit of multiplying, and then we'll do some adding and subtracting. 5 times -4 is -20 minus 5. And then 3 times -4 is -12. So I'm going to write -12, and that equals -37. So now I've got -20 minus 5 is -25 minus 12. And then finally, -25 minus 12 is -37, which of course equals -37. This solution checks out. So finally, I'm going to say the solution set contains the value -4. All right. Let's keep going through examples. Next up, what if we had 4 times x plus 2 equals -28? So this is the first example where we have parentheses. And before you do anything else to an equation, you want to get rid of those parentheses. So let's distribute. So first, we're going to look at 4 times x. Well, 4 times x is 4x. And then we're going to look at 4 times 2. 4 times 2 is 8. So I'm going to go plus 8. And that equals -28. So at this point, I've got a single variable term, and then I've got 2 constant terms. I want to get all of those constant terms on the opposite side of the variable term. So we need to focus on plus 8. I need to move that plus 8. So how do I undo plus 8? Well, I subtract. So I'm going to subtract 8 from both sides. On the left, we say the 8's cancel because 8 minus 8 is 0. 4x plus 0 is 4x. And then on the right, negative 28 minus 8 gives us negative 36. So we've got a single variable term equal to a single constant term. At this point, we've got to do that final step where we undo the multiplication of the coefficient and the variable. So I'm going to divide both sides by 4. On the left, the 4's cancel. 4 divided by itself is 1. 1 times x is x. And then on the right, negative 36 divided by 4 is negative 9. Now, let's go ahead and take a minute and check our solution. This will be the last one that we check. After this, we're just going to go ahead and assume our solutions are good. All right. Now, for you, anytime you feel a little hesitant about a solution, check it. Every once in a while, just to kind of keep yourself on the ball, check your solution. You don't always have to check them, but it's a good habit to get into of just checking every now and again to make sure you're on the right track. All right. So here, we're going to take the original equation, 4 times x plus 2 equals negative 28. Anywhere we see an x, we're going to replace it with a negative 9. So I get 4 times negative 9 plus 2 equals negative 28. Inside parentheses, negative 9 plus 2 is negative 7. So now we need to see, is 4 times negative 7 equal to negative 28? It is. And that's it. So we know that we're good on our solution. So I'm finally going to say the solution set to this equation is negative 9. All right. So for the next problems, we're just going to keep practicing. So for this one, let's say that we have 9x plus 11 equals 8x plus 8. Now, this one is different than the previous three because you've got variables on two sides of the equation. We haven't seen that yet. It's not a big deal. It just is this, the third step of the process of solving is just going to have two parts to it. So first, do we have parentheses? No. So step 2, can we simplify the left or the right separately? Well, no. If we look at the left, we have one variable term, one constant term. That can't be combined. If we look at the right, we have one variable term, one constant term. Again, that can't be combined. So we're now on step 3. Step 3 is where we want to get the variables on one side in a single term and the constants on the other side in a single term. So step 3 is now going to be 2 parts for us. So I like to get my variables on the left. I always like to lead with a variable and say variable equals constant. So we're going to focus on 8x. Positive 8x is the same as plus 8x. Well, how would I undo addition of 8x? I would subtract. So I'm going to subtract 8x from both sides. That's going to give me on the left, 9x minus 8x is just 1x. Drop down your plus 11 and your equals. On the right, we say that 8x is canceled because 8x minus 8x is 0, and then 0 plus 8 is just 8. So we've got all of the variables in a single term on one side of the equation. We want to get all of the constants in a single term on the other side of the equation. So let's focus on this plus 11. How do I undo addition of 11? Well, I subtract, and I'm going to do that on both sides of the equation. On the left, we say the 11's cancel. I did not mean to do that. Let me see if I can fix that. There we go. So on the left, we say the 11's cancel because 11 minus 11 is 0. X plus 0 is just x. And then on the right-hand side, 8 minus 11 is negative 3. So we would say the solution here is negative 3. You, of course, can go back and check your solution. Anywhere you see an x, plug in the negative 3 and simplify. But for now, just go ahead and trust that that is correct. Next up, let's say that we have negative 4x plus 4 equals negative 2 times 4x plus 6. So this one is a little more involved. You can see that we have variables, we have variables on both sides, we have constants on both sides, and for the first time we have parentheses, or for the first time multi-step with variables on both sides, we have parentheses. So first thing we want to do is we want to look at the parentheses. So negative 2 times 4x, I'm going to get 8x, and then negative 2 times 6, I'm going to get negative 12. But the first thing I like to do is I like to go ahead and rewrite what's already there. So even though we're not doing anything with negative 4x plus 4, I'm going to rewrite it. every step to solving, I rewrite what's left, okay? So don't forget that negative 4x plus 4, just rewrite it, and then you can dive into the divide, or to the distributing. So negative 2 times 4x, like I said, is going to be negative 8x. Negative 2 times 6 is going to be negative 12. So now we have a situation where we've gotten rid of parentheses. We need to look to see if we can simplify. Well, the left-hand side has one variable term, one constant term. It's as good as it's going to get. The right-hand side has one variable term, one constant term. It's as good as it's going to get. So we're now at step 3, where we want to get all of the variable terms on one side, generally the left, and all of the constant terms on the other side. So let's focus on moving negative 8x to the left. How would I undo minus 8x? Well, I would add it. So I'm going to add 8x to both sides of the equation. On the left, the 8x and the negative 4x simplify to be positive 4x. Drop down your plus 4 that you already had and your equals. And then on the right-hand side, we would say that 8x is canceled because negative 8x plus 8x is 0. 0 minus 12 is 12. So I've got all of my variables in a single term on the left. Now I want to get all of my constants in a single term on the right. So let's focus on the plus 4. How would I undo plus 4? Well, I would subtract. So I'm going to subtract 4 from both sides. On the left, we say the 4's cancel because 4 minus 4 is 0. And 4x minus 0 is just 4x. And then on the right-hand side, negative 12 minus 4 is negative 16. So we have a single variable term equaling a single constant term. It's time to undo the division of, or undo the multiplication of 4 and x. We undo multiplication by dividing. On the left, we say the 4's cancel because 4 divided by 4 is 1. 1 times x is x. And then on the right, negative 16 negative 3 times 3x minus 5 in parentheses, and that equals 6x. The very first thing I want to do is just take care of parentheses. So I've got 3 times, or negative 3 times 3x, which is negative 9x. And then I have negative 3 times negative 5, which is, let's see, plus 15. And that equals 6x. Now, what's a little tricky here is we have variables on two sides of the equation, but we only have one constant term. Some students will automatically move the negative 9x to the right instead of moving the 6x to the left. I'm a stickler. I really like to always move my variables to the left-hand side, okay? So what I'm going to do is I'm going to add a plus 0 over here, and then I'm going to subtract 6x from both sides of the equation. Again, I really like to have my variables on the left. So I subtract 6x from both sides of the equation. On the left, that gives me negative 9x minus 6x, or negative 15x. Drop down your plus 15 and your equals. On the right, the 6x is canceled. 6x minus 6x is 0. And there was nothing else on that side. So remember, I just added that little 0 in blue. So that just tells me that when the 6x is canceled, I'm just left with 0 on the left, or on the right, okay? So I've got my variables in a single term on the left. I want to move my constants to the right. So let's focus on this plus 15. How would I move it? Well, I would subtract 15 from both sides of the equation. So on the left, the 15's cancel. 15 minus itself is 0. And the negative 15x plus 0 is just negative 15x. On the right, 0 minus 15 is just negative 15. So I've got a single constant, or a single variable term equaling a single constant term. It's time to undo the multiplication of the coefficient and its variable. So we're going to divide both sides by negative 15. The negative 15s do cancel because negative 15 divided by itself is 1. 1 times x is x. And then on the right, negative 15 divided by itself is 1. So we would say the solution here is 1. All right. Let's just keep going with examples. So next up, we're going to kind of up the ante. Let's see, where are we at? How many have we done? F. All right. So we've seen all of the different steps, but now let's put everything in one problem. So here we've got -3 times 3x plus 3 minus 5 equals -6. Let me make that a little clearer. Equals -6 times x plus 4 plus 3x. Okay? So let's see, we've got a little bit of everything in this problem. We're going to start by distributing. We have to distribute on the left and the right. So let's start with the -3. So -3 times 3x is -9x. And then -3 times +3 is -9. Don't forget the -5 and the equal sign. And then let's now distribute the -6 on the right. So we get -6 times x, which is just -6x. Then we get -6 times 4, which is -24. And then don't forget your plus 3x. So we've distributed, we got rid of all of our parentheses. Now we need to look to see if we can simplify on the left and on the right. So looking at the left, yes, I can simplify. I have one variable term, but I have two constant terms. So let's simplify our constants right here. -9 minus -5 is -14. So the left simplifies to -9x minus 14. On the right, I have one constant, but I do have two variable terms. I want one variable term. So -6x plus 3x is -3x, and then drop down your minus 24. So now we have a single variable term and a single constant term on each side of the equation. So at this point, we want to get all of the variables on one side, all of the constants on the other side. So let's focus on -3x. How would I move my -3x? Well, I would add it. So I'm going to add 3x to both sides. -9x plus 3x is -6x. Drop down your minus 14 and your equals. On the right-hand side, the 3x's do cancel. -3x plus 3x is 0. 0 minus 24 is -24. So now I've got all of my variables in a single term. Now I want all of my constants in a single term. So let's focus on that minus 14. How do I undo minus 14? Well, I add it. So on the left, we can see that the 14's cancel. -14 plus 14 is 0. -6x minus 0 is just -6x. And then -24 plus 14 is -10. So we're at that final step. I've got one variable term equaling a constant. We need to undo the multiplication of -6 and x. So I divide both sides by -6. On the left, we say the 6's cancel. -6 divided by itself is 1. 1 times x is x. On the right, here's the deal. When you have something like this where you're not going to divide and get an integer value, you're either going to get a decimal or a mixed number or a fraction. The default is to always leave your answer as a simplified improper fraction. So don't write this as a decimal. Don't write this as a mixed number. Write this as a simplified improper fraction. So we want to divide the top and bottom by 2 in this case. So in the numerator, I get -5 divided by -2, which, or I get -10 divided by -2, which is -5. In the denominator, I get -6 divided by 2, which is -3. But at the end of the day, I'm dividing two negatives, which makes a positive. So I would say the final solution here is 5/3. And that's it. Let's do another one like that has lots of steps. So what if I had -5 times 3x plus 4 minus 4 equals -9 times x plus 5 plus 3x? It's almost identical to the previous example, but let's do it just for practice. So we start by distributing. I'm going to start on the left. -5 times 3x is -15x. -5 times 4 is -20. Go ahead and drop down your -4 and your equals. Now I've got -9 times x, which is -9x. I've got -9 times -5, which is -45. Drop down your 3x. Both sides of this equation do need to be simplified. On the left, I need to simplify my constants. So I've got negative 20 minus 4, which is going to just simplify down to negative 15x minus 24. On the right, I have two variable terms. So when I simplify my variables, negative 9x plus 3x is negative 6x. And then don't forget your minus 45. We're to the point where we have a single variable term and a single constant term on both sides. So let's move all of our variables to the left. So we're going to focus on minus 6x. How do I move minus 6x? Well, I'm going to add it to both sides of the equation. On the left, negative 15x plus 6x is negative 9x. Drop down your minus 24 and your equals. On the right, your 6x's cancel. Negative 6x plus 6x is 0. 0 minus 45 is negative 45. So I've got all of my variables in a single term. Now I need all of my constants in a single term. So let's focus on the minus 24. How would I move it to the right? Well, the opposite of minus 24 is plus 24. So I'm going to add 24 to both sides. On the left, the 24's cancel. Negative 24 plus 24 is 0. Negative 9x minus 0 is just negative 9x. And then negative 45 plus 24 is negative 21. So we're at that final step where we've got a single constant term or a single variable term equaling a single constant term. We need to undo the multiplication of negative 9 and x. We do that by dividing. So we're going to divide both sides by the coefficient of x. On the left, negative 9 divided by itself is 1x. And then negative 21 divided by 9, we need to divide both negative 21 and negative 9 by 3. Well, negative 21 divided by 3 is 7. 9 divided by 3 is 3. And we are dividing two negatives, which just makes a positive. So my final solution is 7/3. All right. Let's look at one more. What if I had 8x minus 5 plus x equals negative, equals negative, and then in parentheses, 8x plus 5. All right, so we do have parentheses. We got to get rid of those very first thing. And one thing I want to note is we just have minus, and then instead of parentheses, we don't write the 1, but really what we're distributing here is a negative 1. So first on the left, I'm going to drop down my 8x, and then I'm going to distribute. So negative 1 times 5 is minus 5. Negative 1 times x is negative x. And then on the right-hand side, negative 1 times 8x is negative 8x. Negative 1 times 5 is negative 5. All right. So we want to simplify. On the left-hand side, I do have two variable terms, and I want one variable term on the left. So 8x minus x is 7x minus 5 equals 8x minus 5. Now, at this point, I want to get all of my variables on the left. So let's focus on the 8x, okay? How do I move this minus 8x? All right. Well, to undo subtracting 8x, I would just add 8x to both sides. So on the left, 7x plus 8x is 15x, and then minus 5 equals. On the right, negative 8x plus 8x is 0. 0 minus 5 is minus 5. All right, so I've got all of my variables in a single term on the left. Let's move all the constants to the right. So let's focus on the negative 5 that is on the left. How would I move minus 5? I would add it. So on the left, negative 5 plus 5 is 0. 15x minus 0 is just 15x. And then on the right, negative 5 plus 5 is 0. But there's nothing to combine that 0 with, so I just write down the 0. And then at this point, I've got a single variable term equaling a constant. So I would divide by the coefficient of the variable. On the left, the 15 divided by itself just equals 1. 1 times x is x. And then what is 0 divided by 15? Well, it's just 0. So we would say the solution to this equation is 0. And that's it. All right, so let's do a quick recap and then we'll look at a couple of word problems. So to recall, solving is the process of isolating the variable to determine its value. The end result of the solving process, you should get the solution, which is the value for the variable that satisfies the equation. And all we mean by satisfies the equation is we're looking for the value for the variable that when we plug it into the equation, we get a situation where the left equals the right. Now, during this entire solving process, we must maintain balance. And we have two properties that we learned in the last video that allow us to maintain balance. They are the addition property of equality, which basically says you can add or subtract on both sides of the equation. And then we also have the multiplication property of equality, which says you can multiply or divide on both sides of the equation. We then looked at the steps to solve an equation. The first step is to eliminate parentheses, use the distributive property. The second step is to combine like terms on the left and the right sides separately. You want to get the left and the right-hand side where each side has at most one variable term and one constant term. At that point, you want to start moving stuff around. You want to get all of the variables in a single term on one side of the equation, generally the left, and you want to get all of the constants in a single term on the other side of the equation, generally the right. And then the final step to solving is to undo the multiplication of the variable and its coefficients. So you divide both sides of the equation by the coefficient of the variable. We looked at a few simple examples, and we also reminded ourselves how to check our solution. You do not always have to check your solution, but it is a good habit to get into where you check every once in a while. If you ever get a solution that you feel just seems off, check it. All you do is take the value that you think the variable is supposed to be, plug it into the original equation, and simplify. If you get a true statement, you're good. So we did a few examples where we checked the solution. We did a few examples where we just kept adding steps to the process. And then we finally got to the point where we did some examples where you had all the steps, where you had to clear parentheses, you had to combine like terms, you had to get variables on one side, constants on the other, and then finally divide. So we did several examples like that. So now what I want to do is I want to take just a few minutes to look at some word problems. Now, this series of videos is going to be quite long, and I'm going to do it in 3 parts. Part 1 is just solving the equations. Part 2 is going to be the part where we really look at problem solving or word problems. So in that case, in part 2 of this series of videos, we're going to be using something called direct translation, where we take words and we use it to create an algebraic expression or to create an equation. At this point, we're not going to have to come up with the equation on our own. We'll be given the equation, but I want you to start making the connections between the words and the equation. Okay, so let's start with an easy example. So this is problem solving. Again, it's easy problem solving because we're going to be given the equation, but all the same. So for this one, the length of a small garden is 6 more than 3 times the width. And we're going to call the width W. The perimeter of the garden is 24 feet. Okay. Solve 2W plus 2 times 3W plus 6 equals 24 to find the width of the garden. And then use the width to find the length, 3W plus 6. Okay, a lot is going on in this particular problem. So I'm going to start underlining and circling things. First up, we have that the length of the garden is 6 more than 3 times the width. Okay, so when you see the length, we know that we're going to take whatever the heck the width is, we're going to multiply it by 3, and then we're going to add 6. Okay, we are then told the perimeter of the garden is just flat out 24. We are asked to solve this equation right here, 2W plus 2 times 3W plus 6 equals 24. We're going to use that to find the width, and then we're going to use the width to find the length, which we already know the length is 6 more than 3 times the width, and this is how you would write it. That's 6 more than 3 times the width, which we call W. So a few reminders. First of all, when you're dealing with a rectangle, the long side, we call it the length. Generally, the short side, we call it the width. So you have 2 lengths and 2 widths to every rectangle. Therefore, the perimeter, you can just add up all the sides, or we can say, well, the perimeter is going to be 2 widths plus 2 lengths. All right. Now, in this problem, we were told that the width is W. The length is underlined in red. We were told the length is 6 more than 3 times the width. So we would take 3 times the width and we would add 6. So that leads us to the equation 2W plus 2 lengths, where the length is 3 times the width plus 6, and that all has to equal 24. So we're asked to solve this. If we can solve this, we'll get the value for W, or the width. So I'm going to start by distributing. So first I'll drop down my 2W, and then I'm going to distribute 2 through 3W plus 6. Well, 2 times 3W is 6W. 2 times 6 is 12, and that is all still equal to 24. Now we want to combine like terms. We've got 2W plus 6W, so that equals 8W plus 12 equals 24. So I've got one term that contains the variable. Now we need to get one term that's a constant. So let's focus on this plus 12. How do I undo plus 12? Well, I subtract. So I get 8W equals 12. We say the 12s on the left cancel, and then 24 minus 12 is just 12 on the right. And then finally, we want to undo the multiplication of 8 and W. So I divide by 8. 8's cancel, leaving 1W. And W equals 1.5. So 1.5 feet for the width. Now the length we knew was 3 times W, which is going to be 1.5 plus 6. All right. Now 3 times 1.5 plus 6, let's see what we get. 3 times 1.5 is going to be 4.5, and then plus 6 is 10.5. So 10.5 feet for the length. And you can check all of your work. All right. Now, if you wanted to check your work, you would just take this equation right here and see if it really is true. So let's go to the next slide. We have P equals 2W plus 2L, W for width, L for length. We decided the W was 1.5 feet and the length was 10.5 feet. So, and then, oh, don't forget perimeter is 24. So we get 24 equals 2 times 1.5 plus 2 times 10.5. Let me put that in a box so we can separate things. So 2 times 1.5 is 3. 2 times 10.5 is 21. And 3 plus 21 is 24. So finally, we could say the width of the garden is 1.5 feet, and the length is 10.5 feet. One thing to always keep in mind when you're dealing with a word problem, write out your answer in sentence form, okay? If we go back to the previous slide right here, some people won't be able to make heads or tails of this. They'll be like, okay, what does this all mean? Whereas if you go here and you give them this, they know exactly what you're talking about. The width of the garden is 1.5 feet and the length is 10.5 feet, all right? So let's look at one more word problem. So this one, we're dealing with overtime. So your hourly wage plus overtime. So Tony worked 45 hours last week, including 5 hours of overtime. Now, generally speaking, a full-time work week is 40 hours. So anything in addition to 40 hours would be considered overtime. And he earned $940. So his total pay was $940. That was 40 hours of just base pay and then 5 hours of overtime. He is paid at a rate of 1.5 times his regular hourly rate for overtime hours. This is pretty consistent. People generally get paid extra money for anything over 40 hours. A lot of times people get paid time and a half is what we call it. And time and a half just means 1.5 times your regular hourly pay. So what we want to do is solve 40x plus 5 times 1.5x equals 940 to find Tony's regular hourly rate. All right, so let's take a peek at this. So we have the regular hours at 40x. So that just means Tony worked 40 hours making his regular pay. Let me redo that. That looks terrible. So that's 40 times x, where x equals the hourly rate. Okay. Now we have 5 times, we have overtime, which is 5 times 1.5x. 1.5x equals time and a half for 5 hours. And then we have total pay, which is 940. So if you take the regular hours plus the overtime hours and set it equal to 940, that's going to give you Tony's total paycheck. So let's see if we can figure out what x is. So we have 40x plus 5 times 1.5x equals 940. First thing I want to do is the 5 times 1.5x. So that's going to give us 7.5x. So basically what's happening here is 5 hours of overtime is equivalent to 7.5 hours of just regular work as far as pay is concerned. So what we would want to do here is combine like terms. So Tony is basically getting paid for 47.5 hours of work. So let's figure out what x is. Let's figure out Tony's hourly rate. So we need to undo the multiplication of 47.5x. So we're going to divide both sides by 47.5. 940 divided by 47.5 is, we're going to round and we're going to say it's 19.79. So we would say x equals 19.79. So let's double check this. So we're saying that Tony's hourly rate is $19.79. So we're going to take the 40 hours of regular pay. We're going to add it to 5 hours of 1.5 times the regular pay. And hopefully that equals 940. So 40 times 1979 is 791.6. And then 1.5 times 19.79 is 29.69. So we get 791.6 plus 5 times 29.69. And we have done some rounding. I rounded here. So if we don't get exactly $940, it's due to rounding in this process. But anyway, we get 791.6 plus 148.45. And we get 940.05. So this right here is simply due to rounding in the process. All right, when I did the work to find x, I actually got, let's see, 19.78947,368, and I rounded up to 19.79. So that's why we get this extra 5 cents. Tony doesn't actually get the extra 5 cents. He's going to get paid those little tiny decimal pieces. But with the rounding, we do get $940. So again, quick recap, solving is the process of isolating a variable to get the solution, which is the value for the variable that satisfies the equation. During the solving process, you must maintain balance. In order to solve, we first eliminate parentheses. We then combine like terms on the left and on the right. Next, you get all the variables in a single term on the left, all the constants in a single term on the right, and then finally divide both sides by the coefficient of the variable. We did lots of examples. The first 3 examples, we looked at solving and checking your solution. Get in the habit of checking the solution every now and again. You do not have to check the solution every single time you solve an equation, but knowing how is really quite powerful, because sometimes you get an answer and you're like, man, that just doesn't feel quite right. You can go back and check. If you get a true statement like we did here, then you know that you're good. If you get a false statement, something went wrong in your solving process, and that would tell you to go back and double check your work. So again, you don't have to check every solution, but it's good to get in the habit of checking every now and again. So each example or each slide, we added more steps to the process. So we saw lots and lots of equations, and then we looked at a couple of word problems. Again, this part of the sequence of solving equations and inequalities, I'm always going to give you the equation. But once we get to part 2, where we're doing official problem solving, we're going to have to take the word problem and we're going to have to create this right here. All right. We wouldn't be given the equation. We'd have to come up with it on our own. So really, when I do word problems at this point, pay close attention to how the words create the equation, so that when you get to the second part of this class or this series of videos, it's not going to be quite as difficult. Okay. So we did 2 word problems, and I tried to break down how the equation came about from the words. So really pay attention to that. All right. So let's see here. There we go. Okay, so that's it for video 3, solving multi-step equations. The next video I'm going to do is going to be on solving multi-step equations that have fractions in them. So oftentimes as students, we get a little flipped out by fractions. It's no big deal. Fractions, my hair looks crazy. Fractions never did anything wrong to you. They're a little bit complicated. They can be a little bit frustrating. So what we're going to learn how to do is, instead of keeping the fractions in the problem and working with the fractions throughout, what we're going to do is we're going to look at eliminating the fractions. So we're going to take a couple of quick steps right at the beginning of the process. We're going to get rid of fractions so that you don't have to deal with them anymore. So that'll be the next video. In the meantime, good luck.